All right, the question says, LP is a vertical lamppost. P, M, and N are points on the horizontal plane. So you have vertical and you have horizontal. And remember, the angle between vertical and horizontal is always 90 degrees. So this angle there is 90 degrees. And this angle here is 90 degrees. Why? Because the line PM is on the ground. The line PN is on the ground. And what PL is vertical. The angle between vertical and horizontal is always 90 degrees. Next, we're told that what two ropes, LM and LN, are attached to the top of the pole. The angle of depression of M and N from L are 41.8 degrees and 30 degrees respectively. So let's try and see if we can illustrate that angle of depression. All right, so that is my horizontal line. This is my line of sight. So I'm at L and I'm looking down at N. That's my line of sight. Now, angle of depression is the angle between the horizontal and the line of sight when you're looking down. So the angle of depression here, this angle between the horizontal and the line of sight is 30 degrees. Let's draw the next line. This is the horizontal. All right, this is the line of sight. The angle of depression there is 41.8 degrees. All right, I don't think that second one is going to be very clear to people. So I'm going to try and draw it from a different view. All right, I'm going to try and draw it from a different view. All right, this is L, this is P, and this is M. This is my 15 meters. This is the horizontal. And the angle of depression is the angle between the horizontal and the line of sight. That angle is 41. 41.8 degrees, 41.8 degrees. So we have two angle of depressions. There's an angle of depression where you're at L looking down at N. That angle of depression is 30 degrees. And there's an angle of depression at L looking down at M. That angle of depression is 41.8 degrees. Now, what we're asked to do next is we're asked to what? We're told that an angle is 40. We're told that LN is 20, is 15. LN is LM is 15. LN is 20. And we're told that the angle MPN, that's the angle in here. That's for the triangle on the ground. So that angle is 45 degrees. We're asked to calculate the length of NP. We're asked to calculate the length of NP. All right, so that will be the triangle around here, around the back there. I'm going to draw it for it to be clear to everybody. I shouldn't need to, but I just want for it to be clear. This is LP, LP. This is 20 meters. This is N. Remember, we're calculating NP. Let's call it X. And we know that the angle of depression of N from L, this angle here is 30 degrees. Now, if that angle is 30 degrees, this is the horizontal. If this angle is 30 degrees, it means that this angle here is also 30 degrees. Let's call it theta. So theta is also equal to 30 degrees. They are alternate angles. Now, its alternate angles are Z angles. So this angle here is now 30 degrees. PNX is adjacent, and LN is the hypotenuse. Now, the ratio that involves adjacent and hypotenuse is cosine. So I'm going to say cos is equal to adjacent over hypotenuse. Then I'm going to say the cosine of 30 degrees is equal to adjacent x over hypotenuse 20. If I have one fraction is equal to one fraction, I'm going to cross multiply. So 1 times x is equal to 20 cosine 30 degrees. X, which is Pn or Np. The examiner said Np is equal to, so this is 20 cosine 30. This is equal to 17.3, and the units are what? Are meter. The units are meter. All right. So NP is 17.3 meters. Next, we're asked to calculate MN. Next, we're asked to calculate MN. That's here. We could call it Y. We just found this to be what? 17.3. We just found this to be 17.3. We're asked to calculate Y. But can anybody see that in order for us to find that? Can anybody see that in order for us to find Y, we need this side here? Let's call it Z. Anybody see that we need to find Z first? Anybody? Let me know. Remember, in order for you to use calculation to find something about a triangle, you must first know 3 things. I knew that the angle that on the ground is 45 degrees. I know that this side, PN, oh Lord. PN.
Excuse me, sir.
Yes.
Sir, you could
I'm listening.
Sir, but do you something there you could do it, sir? Come to actually the Pythagoras theorem to find M1N.
No. For you to use Pythagoras theorem, you need to know 2 sides of the triangle, and you only knew one. All you knew was the hypotenuse, which is what? 15 and 20. You can't use Pythagoras theorem unless you know 2 sides. All right, the way I have it now in the diagram is correct. Pn is 17.3. What we don't know is Pm. Before we can find Mn, we have to find Pn. All right, Pn now. Pm, sorry, I call here Z. This angle is also what? 41.8 degrees. They're alternate angles. Now, this is adjacent, and this is hypotenuse. that is also cosine. So I'm going to say the cosine of 41.8 is equal to adjacent Z over hypotenuse, which is what? Adjacent Z over hypotenuse, which is 15. If I have one fraction is equal to one fraction, I'm going to cross multiply. So Z is equal to 15 cosine 41.8 degrees. Z is equal to Z is equal to 11.2 meters. So back to our diagram, this we just found is 11.2 meters. And now we're now asked to find MN, which is here. So let's draw our scenario. This is the scenario we have. Let me turn the page. We know that this is 17.3. This is 11.2. The angle here is 45 degrees. And we want to find this, which is Y. This, I think, is what? N. This is M. And this is T. This is our scenario. Now, I just need one person to tell me. If I have two sides of a non-right angle triangle, and the inclusive angle, and I wish to find the length of the third side, what must I use? Anybody? If I know two sides of a non-right angle triangle and the inclusive angle, and I wish to find the length of the third side, what must I use?
Cosine.
I'm going to use the cosine rule, which says that what? A squared is equal to B squared plus C squared minus 2BC cosine A. That's the formula. Let's change the ink. From the formula, this is A. The inclusive angle is always A. The side that you want to find, that's letter A. This would be B, and this would be C. Put in the values, we have what? Y squared is equal to 11.2 squared plus 17.3 squared minus 2 times 11.2 times 17.3 square, sorry, not square, the cosine of 45 degrees. Now all we have to do is work this out and don't make any mistakes. 11.2 squared this is 125.44 plus 17.3 squared, which is 299.29 minus 2 times 11.2 times 17.3, 387.5 to the cosine of 45 degrees. This is 424.73 minus 387.52 cosine 45 degrees. This is y squared. Now the opposite of square is square root. all I have to do is find the square root of this. Y squared is equal to all of that. So if I want to find out what y is, which is mn, I need to find the square root of all of that. All I have to do is put it exactly like how you see it in the calculator and press equal. We must remember to use those brackets. Without the brackets, you're going to get it wrong. So it's going to be square root sign, open bracket, 424.73 minus 387.52, the cosine of 45 degrees, close bracket, equal, and y, which is mn, would have been equal to 12.3 meters. Mn is 12.3 meters. Did anybody get it correct?